Once you determine the root bridge and the root ports within a topology, it's time to identify the designated ports. The designated ports, just like the root ports, are in the forwarding state. They are going to be sending frames, receiving frames. They'll also be populating the MAC address table based on the source MAC address in those frames that are being received. So they're in the forwarding state. They're actively participating with the forwarding of information within the spanning tree topology. When it comes to designated ports, there can only be one designated port per link, per segment, per connection between switches. However, there can be multiple designated ports on a single switch. Also, since the root bridge cannot have root ports, and you never ever want the root bridge to block a port, because remember, everything is growing from the root bridge, from a tree. If you have a real tree, if any of the internal methods of moving water through the tree ever fails, ever gets blocked from the root system, what's going to happen? The tree is not going to fare so well in one certain area. Same idea here. You do not want to block ports on the root bridge. Well, that means every port on the root bridge has to be in the forwarding state. So if every port on the root bridge has to be in the forwarding state, what is our option? Well, it can't be a root port, so it has to be designated ports. This is a shortcut, folks. So without even doing any calculations, you can automatically label the ports on the root bridge as designated ports. They're in the forwarding state. They're sending and receiving frames, learning MAC addresses. Also, another shortcut, based on the fact that you need one designated port per segment, you already know that port 2 on this segment or this switch is a designated port. Why? Because the other side's a root port. And you need one designated port. So let's label that as well. So based on those two shortcuts, or knowing how the designated ports operate or where they have to be, you have already figured out three of the four designated ports. Since you need one designated port per segment, we have 4 segments or 4 links. Therefore, we need 4 designated ports. We already have 3. We're 3/4 of the way to figuring out the designated ports. So what's left? This one link at the bottom. This is the way I like to figure out designated ports. I position myself in the middle of the link. And I point in both directions. And when I point in both directions, I ask myself, what is the quickest way to get back to the root bridge from this spot on the link? It's based on cost, just like the root port calculation was. And cost is cumulative. So if we add back in our costs that we had for the topology, 2, 2, 2, and 2, if I take the green path, I have 2 to get from here to here, and 2 to go from here to here. That's 4 in total. If I take the red path, I have 2 plus 2 plus 2 is 6. 4 versus 6. Lower is better Therefore, I want to go on the green path here. I want to take the green arrow. Therefore, that is where the designated port is going to be. So I'm pointing to the designated port now because it's the shorter way to get there. So let's label that. This is our designated port for this link. So what does that leave us with? It leaves us with one port right here. What is that port? Well, walk through the steps. Did you find the root bridge? Yes. Did you find the root ports? Well, one root port per non-root bridge. We have 3 non-root bridges, therefore 3 root ports. Done. Did we find the designated ports? 1 designated port per segment. 4 segments. 4 designated ports. Check, 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 check. They're all there. 1 there, 1 there, 1 there, 1 there. What does that mean? All other ports are blocked. All other ports are blocked. There's our blocked port in this topology.